Okay, so we're going to look at a couple examples on how we can compute and kind of interpret the standard deviations and variance of data sets. Okay, so the first example we're going to look at, we're going to describe variability. We're going to try to use this with we're going to find variance, okay, but it all starts off with looking at deviations. Now, again, deviations are going to be the mean, or excuse me, our observation minus our mean, which is x bar. So first things first, we have to find what our mean is going to be. Okay. Once we find our mean of this data set, then we can go through and find everything else that we need. So here we've got 7.69 for U and 6.79, and this is 6.18 and 2.87. So these together make 13, 14, 49. And these two together make 8, 905. So we've got 2354. And we need to divide that by 7. So we end up with 321. 336. You know, we'll go with 336 here. That's going to be our mean. So we're going to go back and we are going to now take each of our observations and we're going to subtract away 336 from it. Well, we should get all of these answers here. So that's all that is each of these minus 336 all the way down the line. Okay, so this information, again, we looked at in our constants video. If we add these up, it's not going to help us because we're going to get 0, or a number very, very close to 0 if we rounded, which we did in this case. We did round. So we could end up with a number that's slightly different than 0, but you get the idea. Well, instead of doing that, what we decided to do is we square each of these and then add them all up. So what we end up with, you know, 0.34 becomes, or negative 0.34 becomes 0.1156, and so on and so forth, and you end up adding all of these up together. So the sum of our squared deviations, which is what this means here, is 2.4643. Now that's not, again, very useful to us because it doesn't kind of deal with how big this set is. Well, if we want to deal with how big this set is, we need to divide by the number of observations minus 1. So we're going to take this 2.4643 and we're going to divide that by 6, which is n minus 1. So we're doing this over n minus 1, and that gives us our sample variance. So if we do this, we end up with, so this is 4, 0 versus 0, 4, 3, 7. So we're about 4.107. No, 0.4. Apologize, 0.4107. That makes more sense. Okay, so that's about it. So that is our sample variance for this. Now, if we wanted to find our standard deviation, we would take the square root of that. But that is how we get this as a judge for variability of our data set. And we'll see when we compare these numbers later when we work with them how important they actually are. the next thing that we talked about doing was the interquartile range. So if you have a bunch of data, you want to see roughly how spread apart it is. A good way to do that is to obviously order it and figure out, how far apart is, some of the lower end from my higher end. That's a good way to judge, where is the middle of my data. That will tell me how spread things are. So we have all this information about percentage of the population who have a bachelor's degree or higher in 2007 for each state. So these are all percentages. Obviously, we've got some low ones, we've got some pretty decently high ones, and so on and so forth. But we're going to go through it again. This is 51 data values because we are adding in DC down here. So if we have all these data and we want to look for our interquartile range, we've got to order it first. Okay, so we need to order it, from low to high. So we have 17 at the top, 47, or 17 on the bottom, and 47 on the top. So in between, we order everything. Well, just so happens because we have 51 observations that we do have a middle term. So that is going to be our 26th term. Funny enough, the actual number is 26. So we get that. That is our median. So this is where 50% lie. Well, now we need to figure out what's the median of the lower half and the upper half. Well, what is that median? Okay, so we're going to have our median is 26, and that's 50 percentile. Well, if we look at this data, we should have 25 points of data for each of these. So we need to find the 13th. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Right? So that is the middle data point for the lower half, or that is the first quartile, which is at 25%, and that is a 24. Well, then we have to do the same thing for the upper half. So we were looking for our third quartile. Now, our third quartile is going to be at 75%. So we need to count to the 13th observation again. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So this is a 30. So one way that we can measure how varied data is by looking at the difference between our third and first quartile, which in this case we would have our IQR. That's going to be 30 minus 24, which is going to be 6. Now obviously we need to know exactly what we're talking about to understand what that 6 really means. But this is a number that we use to describe how data is spread out and varied in a data set.